Okay, so we're going to have a wee look at assembly inside Fusion. Now in traditional CAD packages, what you would do is you would assemble components together and try and reduce their degrees of freedom. So whether they can move in X, Y and Z and rotate in X, Y and Z, you try to remove the degrees of freedom that they have in order to create the motion that they would have in real life. Now, Fusion does this slightly differently in that it basically locks down everything. So all degrees of freedom are locked down, and then you release the degree of freedom that you want to get the motion that you need. And there's a few things that as you do the tutorials on this, you'll kind of understand, but at the most basic level, what we're going to do is we're going to have a look at this little setup in the file that I've given you. So you should have a file in your Moodle or your download or the folder with the course files called Joint Basics. Okay, there's a few things in here I want to point out before we begin. So everything is a component. Okay, so you know that you come in and you create new components. And at the top level, we've got a root node and it's called Joint Basics. So everything inside here is covered by this Joint Basics file. And then certain things, like if I look at this slider joint here and I explode that out, you'll see that we've got the slider joint component, and inside there we've got another component called the slider bar, which if I pick on at the moment you can see is this wee thing here. Okay, so these are technically sub-assemblies, and each of these is the type of movement that we're going to try and show you how Fusion creates these assemblies with. So we've got fix and revolve, we've got a slider joint, we've got a cylindrical joint, we've got the pin slot, we've got planar and a ball joint. Okay, so combinations of these will help you to make your assemblies move in the manner in which they would in real life. A couple of other things that we have are, if I look under the joints folder, so as soon as you apply a joint, which is under the assemble menu, you get a folder appearing at the level that the joint was applied. So I have levels at the top where I have told the base unit here, so every one of these boxes that the things are sitting on, to be a rigid joint to the top level of the file. So basically these things cannot move. Okay, and I've got a thing in here called contact sets, which we should remove, and maybe in the file I've given you they're not there, but I'm going to just delete these at the moment and we'll put them back in afterwards. So anytime you create something new, you'll get a folder. And if I go down to the slider joint again, you'll see that inside each of the components you've got origins, bodies, sketches, and if I create a joint with inside here, inside this slider joint, it will appear in its own folder underneath the sub-assembly. Now, another thing that we have here which is quite handy is this thing called named views. So at the top, just below the root, you should see like document settings, which will give you your millimeters, meters, etc., whatever units you're using. And then we've got different views. So these are set up by the software, and they are views that are easily accessible and you don't have to use the view cube to get to them. Okay, and they also allow you to create your own views. So if I click on named view, I can say I want to create a new named view. So what I've done is I've created a view by just zooming in on the thing that I'm interested in and manipulating around to the direction I want to show it, and then do save new view basically. So you see here, if I do fix revolve, it jumps to that one. If I do slider, it jumps to that. If I do cylindrical, it goes to there. If I do pin slot, it goes to there. planer that goes to there, and ball that goes to there. Okay, so this is quite a handy thing to have. And this is also how you set up your views to keep it like a camera view for your rendering. If you had to render something and you wanted to keep that view constantly, you can save it as a named view, and then you can always get access to the same positional view that you need. So let's return to here. Let's stop the video and we'll continue this in the next lesson. Okay, so continuing on, what we're going to do is we're going to apply these joints and see how they operate, and then, as I say, you'll carry on with a series of tutorials from Autodesk themselves on this, and hopefully at the end of that you'll have an idea of how to put a model together and make it move. Okay, so first thing I want you to do is to come up to our named views, and then double click on this one here that says Fix Revolve. Okay, so we can close that down again. So what we have here is we have the parts that are fixed to the top level. Okay, so you always have to have a part that's fixed or grounded. So if I right hand mouse button on this part, let me go down and say Fix and Revolve ground. Okay, so what you can do is you can ground it, but this can cause problems sometimes depending on the complexity of your assembly. So what I would say about the ground is that you can apply it, you can start to move your object about and get its movement, and then maybe delete this or remove the ground or unground it. And then what I tend to do is, if I don't want something to move, I create a joint between the object and the root node. So I have done that, and this is what's shown in these folders here. Okay, so this one, for example, should be a connection between the root node and this part to tell it that it cannot move. So if I right hand mouse button on this rigid joint, it gives me various options. I can edit it, I can suppress it, which means that it won't be active anymore, or I can animate it. And when I animate it, you see it's rattling about, but basically what that's saying is this is fixed, so it cannot move. Okay, and I hit escape to cancel that. But that relation, this joint here has no relation to this purple part. Okay, so what happens if I move that purple part? So if I grab that with my mouse and I move it, you'll see that it can move because none of its degrees of freedom have been locked to anything. And I have these two options appear here. Okay, capture position and revert. So capture position is, if I've moved this and I want it to be in this position, I can click capture position and it will stay there. If I hit revert, it will go back to where it was before. Now sometimes when you're building an assembly and you want to see if a part's connected or how it moves, you can drag that, and if it moves how it's, differently from how you expect it to move, then you can hit revert and get back to where you were and then apply a joint. So I'll show you how this kind of works. Okay, so if this part was away out here and I wanted to join that onto here, then I can use this option here, which is joint. Okay, or J on the keyboard. It positions components relative to one another and defines the relative motion. Okay, so that's fine if this was a part that we brought in, or we'd made it somewhere else and we suddenly wanted it to join on and have motion. But because we've designed this part in place, because that's kind of how Fusion works, you design things in place, it's top-down modelling. So this component is actually exactly where we want it to be. So rather than dragging it away and then hitting the joint and applying the joint, Fusion has this other thing here called an as-built joint, which is a shortcut Shift J on the keyboard. Okay, now what the as-built joint is basically saying is, this part is exactly where I want it to be, but I now want it to have motion of some description. And you get a whole list of different types of motion depending on what you want to do. Okay, so for most of the exercises within this little bit of the tutorial, you will be using what's called an as-built joint. Okay, so it's underneath here, and I've got it on the toolbar because I've gone to these three buttons here and I've put pin to toolbar. So if you want it up here permanently, that's how you do it. So I'm going to apply an as-built joint. So the first thing it asks me over here is what components do I create this as-built joint between, and then the type of motion that is going to be created between those components. And you see that we have different types. So there's rigid, there's revolute, there's slider, cylindrical, pin slot, planar and ball. And this exercise is basically to show you what all these are. Okay, so the first one we want to try out is rigid. So we can set that motion first, or you can pick the components and set the motion afterwards. It's entirely up to you. Okay, so the components, you can pick them in a certain way. I would always pick the component that is going to move, or is moving to something, to the one that's fixed. Okay, so the first component I want to pick is the purple one, and then pick the blue. Okay, that's two components. That little shake is Fusion's animation to show you that that's fixed. So the two of them are moving together because they're fixed together and they cannot move. Okay, so that, if I hit OK, what happens is, if we look down here, we've got a rigid joint that's been applied to fix and revolve component. Now if I go to the joint folder here, you see that it's not been applied at the top level. It's been applied inside this component. So if I come down to here, I now have, as you see there, a joints folder for the purple part and the blue that's created its own joint folder, and I have this joint here called rigid. And if I select that, I can right hand mouse button and say edit the joint, which would allow me to change it to something else, which we'll do in a minute. Right hand mouse button again, suppress. Now suppress is basically you get rid of the joint that you've created, but you can bring it back. So there might be times where you want to suppress something to get a movement of something else, and then return that once you've done that, once you've created the type of movement you're looking for. The next one here is animate the joint, so that will show you what's going to happen when that joint is applied, or what's happening when that joint is applied. And again, to get out of there, you hit escape. You can delete it, you can select the components, etc. So what we want to do now is, you see here that I can't now move that because it's fixed. Now what if I wanted to make this a revolute joint? Okay, so I say I'm going to edit the joint, and then I've still got the two components picked, but this time I want to apply a revolute joint, and it gives me one other thing to apply, which is the position. So the revolute joint is revolving around one axis. So at the moment it knows the two components, but it doesn't know what axis you want to roll around. So you see as I move my mouse, it's picking up different different edges and vertexes and faces, etc. So we want this to go round the centre of this. So I could drag my mouse in, try and get the centre. I can pick the edge, I can pick this edge, and the other thing I want you to look at is the way the symbol flips depending on where your mouse is. Okay, so we want it to go around this top bit. As soon as I do that, it starts to spin. Is that the axis that I want it to rotate around? Possibly yes. But if I wanted to, I can change it to revolve around that axis, or to revolve around the x-axis. Okay, so sometimes when you apply this, you know, it might be going like this, and you panic and you think, oh, that's totally wrong. But really, what you can do then is just change the axis and get exactly what you want. If I click OK, because I edited that, it's not made a change to the tree, it's still the same one, but that is now, as you see in here, a revolute joint. And because it's not fixed anymore, it also has the ability for you to apply, if I hit the right hand mouse button on here, joint limits. So this is how much do you want this to rotate. So let's say I want it to rotate 90 degrees. Click OK. Then I can only go 90 degrees. Okay, so pretty simple. Seems simple to begin with, but they can get pretty complicated. Okay, so we'll continue this in the next lesson. Okay, so let's close the fix and revolve, and we'll click the slider joint. Okay, so this is the one that we want to get to. So we have to go to name views and double click on slider, and that will show us this setup. So basically we've got this little kind of like a vice thing, and this thing's going to slide along here. So again, it's an as-built joint because this is in place. We don't want to have it way out here and then have to try and assemble it. We'll just click revert. So we're going to create an as-built joint. The as-built joint is going to be between this component and this component, and it shakes because we've still got our motion set to rigid. So let's set it to slider, and as soon as we set it to slider, it starts to ask for a position. So where do you want this to slide along? And again, you can see, depending on what face or edge or vertex you pick, you'll get different directions of slide. So in our case, we want it to go this direction. And to make it work, you actually have to just click off. And there you can see the movement that this is going to give. So again, you can pick a different axis, but the Z axis is definitely the one that we want this to run along. So now I should be able to just pick that and drag it. But you notice that it's going off the end. So if we click revert, we have to do a thing called editing joint limits in order to get this to move how we expect. So if we expand the slider joint and we come into the joints folder, you'll see over here it has this little symbol that says edit joint limits. So if you click on the actual word slider here and right hand mouse button, you get various options down here, including drive the joint, which will allow you to physically drag it. So that will tell us here, for example, that it's pretty much 65mm to get to there. So now we know a distance from 0 to 65 is the distance we want this to slide along. If we click on that again, we have edit the joint to change it. You've got edit joint limits, which is the same symbol as this little brown one that appears here. We've got lock, so you can actually lock it so it can't move at some point. So I could arbitrarily move this to the middle and then lock it there so that I could do something else and then release it. We've got suppress, we've got animate the joint. Okay, and again hit escape to come out of that. And then you've got animate model, which at the moment looks the same, but if there was connections between this and something else, then the whole connection of how the thing would move would be animated so you could see how it was going to work. And again, hit escape to stop that. So we want to edit the joint limits. Now this is kind of confusing because this minimum maximum thing doesn't really make sense. In one of the forums I found a guy complaining about it, and basically he's written, the joint limits box dialog implies that one can establish a minimum limit, a maximum limit, or both. It seems that this is not really the case. One can only assign minimum and maximum limits at the same time, or no limits. The ability to assign either or both is inferred by the dialog window presenting a checkbox, which is this thing here, with minimum and maximum limits. While this may technically be a bug, the actual functionality seems inconsistent with the options offered to the user. And Autodesk have got back to them to say that they're going to look into this problem, but one of their expert guys has written, I see what you mean, but isn't when there's a maximum, there's a minimum. I don't understand this. So if maximum is 20 degrees, the minimum should be minus 340. And it's like, no, let's just have a 0 and then how far you want it to go would surely make more sense. So as I say, this is particularly annoying. So as far as I can gather, this is 0, and whether you pick minimum or maximum, it's going to be the same kind of value. So let's pick minimum, and then say that what we want is to go 65. Okay, and it seems to have accepted that, and I'll click OK, and that means that I should be able to slide this guy in the wrong direction. This is what I mean about it. So let's go back into here, edit joint limits. So I want to flip that direction, click animate. So it's going that way by 65, so it says, or is it? So it's fine there, comes off the end there. So how do we stop it going off the end there? So let's try again, click edit limits, maximum 65, minimum 0, click OK, and there we go. As I say, you might find yourself in a lot of problems with this, but that has worked. Okay, so we've told it the limits it can go. Now another way, rather than driving the joint, is to find the distance that you would need for that, is to use the inspect tool here and measure. So I'm going from here to here, 65 mil. That'll tell you the limits that you have to put in the joint. Okay, slider's probably one of the worst ones that I've seen. So, but you can get it to work if you play about with it. Okay, so we'll continue in the next lesson. Okay, so let's go into the next one. So let's close this slider joint thing down, go to name view and double click on cylindrical. Okay, now I'm assuming that the colours that you get are the same as the ones I have in my folder, because I'm giving you this file. And sometimes the colours in this might be kind of rubbish. Okay, so these two are pretty close to each other. So what you can do is I can come in, click this cylindrical spinner part, right hand mouse button, and then if I come down here I'll have this option, cycle component colour, and that will change that to something that's more applicable and easier to see. Okay, so this one we're going to apply a cylindrical joint. So a cylindrical joint allows it to move up and allows it to spin round. Okay, so let's apply it and then we'll see how it works. So we go to an as-built joint between this component and this component. It's not a slider, it's cylindrical, and again it's looking for a position, so we want it to slide up and down around this axis here. So if we click on there, you'll see that that in the Z axis is the direction that we want it to go. Now if I drag this and twist it or whatever, you see that it will always give me the revert back and capture position or whatever. But like before, I would like this to not go down through the part. So we have two options. We can go through the joint limits again, or we can apply another thing called a contact set. The contact sets are quite intensive on the computation behind the scenes. So I wouldn't put them on everything, but sometimes if you've got something that just demands that, you know, two faces hit each other, it can't pass through, like this component here, and it's such a simple thing, then we can easily apply this. So under the assemble menu, if you come down, you'll see you have this thing here called contact set. Okay, so if you click on that, it should come up into here and say bodies and components. So we want a contact set between this component and this component. Click OK, and you see up here we've now got this folder where you can also create a new contact set. Now what I would never do is this thing here, enable all contact, because if you've got something that's got say 200 parts and you click enable all contact, it's going to have to do all the calculations of how these things collide and etc, and it can just absolutely cripple your machine. So this is for something like as basic as this, but for us we can just leave it off. Our contact set, if we wanted to edit it, we can click on it there and do edit, and we can suppress it. But basically all it's done is it's told that you still have the movement that you have put on from the joint, but when you get to there, you cannot bump through it. Okay, it cannot pass through that part. Okay, let's continue this in the next lesson. Okay, so next one we want to do is the pin slot. So if we come up to name views and then double click pin slot, that'll take us over to this. Okay, so in here what we have is we want this to slide along here and we want it to rotate as well. So how do we do that? We do an as-built joint between this component, that component, and the position we want is to rotate about here. Okay, so that's definitely the motion that we're looking for. So we can spin it and we can move it, but as you see it can pass right through everything. So we know that in order to stop that happening, what we can do is we come over to contact sets over here, right hand mouse button, a new contact set between bodies and components, between this component and this component. Click OK, and then if we look down the contact sets we should have two. So what you could do is you could say this is pin slot contact. So doing things like this will keep it in your head as to what these are when you start to want to make changes to them. And then hopefully what we've got now is, see, you can spin it but it can't come out from that slot. Okay, so believe me, this method is so much simpler than it is in other CAD packages. So if this starts to get confusing and you start to find yourself thinking that this is a terrible way of doing things, believe me, this is not. This is genius compared to the other way of doing it, where things would just shoot off into space for no apparent reason. Okay, so bear with us and we'll get there. Okay, so there's only two left, so again up to name view, we'll do planar, and again, an as-built joint between, so it's got one component picked, so let's make sure we've got nothing picked between this one and this, and it's not a slider, it's planar. And again, the position is going to ask you where do you want it to move along, and this one we want to go along here, and then if I click you'll see that it's going a bit crazy. So what we can do is we can add another contact set. So if we come down to planar, make that active, and then we're going to add a contact set, new contact set between this one and this one. Okay, and then if we pick the joint and say drive the joint, should be able to move it about, and it shouldn't really go outside of that, but you get the general idea. Okay, so let's come back up to the top level. Let's close that one down, and then the last one is the ball joint, and again we're going to, let's put this to revert, let's go as built joint between this component and this component, and the position for the ball joint is going to be in the middle of that big one there, and you can see the type of joint that creates. Okay, so that's basically it. So what we're going to do is you're going to do a series of tutorials now from Autodesk themselves that should enhance your knowledge of joints. So instead of an as-built joint, you'll be actually using the joint tool. So once you've done that, you can then look at the video that shows you what your submission is for this part of the course. So you'll be given a series of components, and you'll have one component to make, and then you'll have to assemble them together and get the motion that this assembly requires. Okay, good luck. Okay, so for the next set of tutorials, what I want you to do is we are going to use, let me shove this up in here, Autodesk's own tutorials from their help menu. Okay, so what we can do is, let me minimise this to start with, is if you come up to the help up in here, and what you're going to type in there is design assemble. Okay, and from the help menu, so let me drag this back in, this is going to give us something that looks like this. So what I want you to do is to come to this tutorial top down design method of assembly under product documentation. Okay, and then if we go to this one here, tutorials, you'll see that this area consists of a series of lessons to walk you through the core Fusion 360 workflows in the assemble contextual environment. Okay, so I want you to do all 4 of these, and obviously I'll be checking your files when you're working on them, so I can go in and see and make sure that you have done them. Okay, now all of the parts that you're needing in order to complete these exercises are found if we go back to home and we slide down and we go to basic training and we come down to assemblies 06, then everything that it's asking you to use, there's the tripod, there's the base, etc. So these things, the piston linkage, these are all part of this exercise. So what we need you to do is to come to here and follow the instructions from the tutorial. So again, let me show you the page. So what you would do is you click this one using top-down method of assembly, come in here, you can click there and it will give you another lesson about as-built joints and joints. Takes you through both of these activities. So the first one is create components and add as-built joints. So you click on there and literally follow exactly what it's asking you to do from this little lesson here. Okay, so the first one you're going to learn about as-built joints. The second one, you're going to take this tripod and you're going to apply different types of joints to that. Okay, the next one, we're going to assemble this clamp together and make it move. And the next one, you're going to have a play about with this sub-assembly and as-built joints. And in the last one, I want you to do this Geneva mechanism, which should allow you to see about collision detection and contact sets and motion analysis. Okay, so you need to have each of these completed and in a folder so that I can see that you've done them. Alright, and then we'll do our own little exercise after that.